In this video, we're going to work on the second part for this review, questions 11 through 20. Question number 11. How many different codes of 4 digits are possible if the first digit must be a 3, 4, or 5, and if the code may not end in 0? So first of all, it says 4 digits. So 4 digits means 1, 2, 3, 4. If the first digit must be a 3, 4, or 5, so the first digit can be a 3, a 4, or a 5, so you have three numbers to choose from. And if the code may not end in 0, so that means you can only have numbers 1 through 9, so that makes it 9 choices from 1 through 9 instead of 10 choices. Since it cannot be 0, you can only choose the numbers 1 through 9. There is no mention of any restrictions for the second digit or the third digit. So that means that if you can choose any numbers between 0 and 9, that's 10 choices. Any number between 0 and 9, that is 10 choices. So all you have to do is multiply 3 times 10 times 10 times 9, and that will give you 2700. So this one is letter B. So on number 12, classify the events as dependent or independent, events A and B, where the probability of A is 0.4, the probability of B is 0.4, and the probability of A and B equals 0.16. In order for them to be independent, that means that the probability of A times the probability of B must be equal to the probability of their intersection. So the probability of A is given to you as 0.4, the probability of B is given to you as another 0.4, and that equals 0.16. So therefore, since the probability of the product is equal to the probability of the intersection, these two events A and B are independent. So that will be answer B. The events A and B are mutually exclusive. What that means is that they do not intersect. They don't have any numbers or outcomes in common. Do not intersect. If the probability of A is 0.6 and the probability of B is 0.3, what is the probability of A and B? Well, the probability of A and B is equal to 0 because they are mutually exclusive. They do not intersect. So this can be a tricky question, so the answer is B. Classify the events as dependent or independent. So they're giving you the probability of A is 0.4, the probability of B is 0.2, and the probability of A and B is 0.7. So again, in order to decide whether they're independent or dependent, this must be satisfied. The probability of the product must be equal to the probability of the intersection of the products. So the probability of A is 0.4, the probability of B is 0.2, and it's given to you that the probability of A and B is 0.07. Well, the probability of 0.4 times 0.2, if you were to use a calculator, 0.4 times 0.2, you'll get 0.08. So this gives you 0.08. So this is not equal to what they're telling you. This is not equal to the 0.07 that it says that the intersection is. So their given intersection is 0.07, but the product of the two is 0.08. Therefore, on number 14, they are not independent, they are dependent. Number 15. A group of students were asked if they carry a credit card. The responses are listed in the table. If a student is selected at random, find the probability that he or she owns a credit card. Keyword, given. So when it says the word given, this is the conditional probability. So the probability of a credit card given that is a sophomore. So the probability of having a credit card given that the student is a sophomore. This is equal to the probability of the credit card and the probability of the sophomore divided by the probability of a sophomore. So the probability of credit card, and so what happened is sophomore. So therefore, for number 15, I am only going to be looking at these numbers. So the probability of credit card, and sophomore, that's 31. And the probability of sophomore is 40. So the denominator will be the probability of sophomore, which is what is given. And the numerator is the intersection of credit card and sophomore. So you will enter that in your calculator, divided by 40. And that gives us 0.775. And that is answer A on number 15. You are dealt 2 cards successively, one after the other. Keyword: without replacement from a standard deck of playing cards. Find the probability that the first card is a 2 and the second card is a 10. So what is the probability of a 2? And then it says, and the probability of the second one, a 10. So the probability of a 2, in a standard deck of cards, there are 4 2s to choose from, 4 out of 52. And 10, there are also 4 10s, but this time is 4 out of 51. So you multiply across, that is 16 over the product of 52 times 51, 2,652. So what we're going to do is 16 divided by 2652. So that gives you a long decimal, but you can go to math, enter, and that simplifies to 4 out of 663. So it doesn't seem that it can be simplified any further. So on the next one, sorry. This one doesn't go here. This answer is here. 4 out of 663. So as a decimal, math, if I want to turn that into a decimal, 0.006. So as a decimal is 0.006. So that is A for number 16. On number 17, decide if the events are mutually exclusive or not mutually exclusive. Mutually exclusive, that means they no intersection, no overlap. And mutually exclusive, they overlap, or they have something in common. So the result, a die is rolled, the result is an odd number. They have options, or the results may be a 1, a 3, or a 5. Even number, the even numbers are 2, 4, 6. So these two sets, they don't have anything in common. Therefore, they are mutually exclusive. So I highly recommend that you set it up like this and then look back at the definition. No outcomes in common. Nothing in common, that means that these are mutually exclusive. The next one, a die is rolled. Now for the part A or event A, you roll a 3. For B, odd number. The odd numbers are 1, 3, 5. They overlap with the 3. So they have 3 in common. So since they have a number or something in common, they are not mutually exclusive. So that one is B. So now we move to question number 19 and 20 to finish this video. So on question 19, a card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace or a king. Ace are the ones with the letter A, and there are 4 of those. Kings, there are 4 of them. So it says an or, so the probability of an ace, there are 4 out of 52. The probability of an ace, 4 out of 52. So they don't have anything in common, so I don't have to remove any overlap. 8 out of 52. And again, we need to simplify that fraction, and you can use a calculator. 8 divided by 52, math, enter, and the calculator will simplify for you. So this one is 2 out of 13. The answer is letter B on this one. Number 20, a card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace on a black card. So the probability of an ace is 4 out of 52. Black card, half of them are black, so 26 out of 52. So this is 30 out of 52. And again, demonstrating how you can use the calculator to simplify this fraction. So 30 divided by 52, press math, enter, enter, and you get 15 out of 26. So if you are allergic to fractions, use your calculator that I call Dora. Thank you.